Hello guys, I'm back. This is a follow-up video. I had a couple questions in the comments. Actually, it's basically the same question, and that was kind of dealing with how's that triangle and the figures and dealing with it and how you figure it and what you're doing with it, how it relates to the circle. How can they be the same thing? Well, without getting too complicated, and actually it's not, it's really simple. When you look at the triangle, you know, I had put H on here, and I think my marker's about dead, but for hypotenuse, and actually a capital H is really the wrong letter, should be a small h, but that works. Alright, well, when you look at the circle, this is also H, this line. That's a hypotenuse. It's also known as the terminator. Angle theta, or whatever you want to call it, but it's the same angle. So how is this the same thing as a triangle? How the two? Well, it's real simple. You just take from the point where the hypotenuse line or terminator intersects a circle and come straight down. And when you're doing a right triangle, you always just, standard procedure is just put a little square in there just to kind of show that that's what you intend it to be. And there is your triangle. Same thing. Same two triangles, basically. I didn't draw them to absolute scale. My drawings are not the grandest. I usually use high quality tools to draw stuff. Like when I want to draw a circle, I use these extremely expensive tools. Another one is a CD, coffee can, whatever. Draw straight lines, yeah, rulers. So that's how the two relate, because the triangle is actually just inherently inside the circle. And so the opposite side, O, is this line. And that works out to be just, it's a parallel line to Y. It's a vertical. And then the adjacent side, A or capital A, either way, is basically x-axis here, or something that would be parallel to the x-axis. Now, why use a circle? Why is that important? Well, right off the bat, the main reasons, you know, and I was going to get into this a little more, and actually I should have drew this yesterday, and I'm sorry that I didn't. The circle was pretty small. I wanted to get a bunch of other information on there, and the primary thing I was wanting to do there was more or less set up the ratios and the functions and define the functions. But triangles are generally more or less for what is known as triangulation. And actually trigonometry is the math of triangles. But triangles are generally used, and they teach them trig using those mostly in high school or trig. But you can use these for, you'll be using something like that if you're doing navigation, or if you want to make certain measurements, maybe you want to find the height of a pole or something like that. And you know, it's pretty simple. If if you looked at this triangle and consider you got a pole here, it's unknown height. I mean, it's tall enough you cannot actually physically measure it without, you know, without ladder or other equipment such as a bucket truck or something of that nature, which is, you know, a machine that lifts people up, or a man lift or whatever. You're not going to be able to measure it. But it's a sunny day out and it produces a shadow coming out. All right, so you got the shadow, you can measure the shadow, and that's making the assumption that the pole's straight up and down. Okay, it's plumb, it's going straight up and down, and the ground's relatively flat. So you measure your shadow, and you take whatever means, and there's several different means, but to visualize a line going from this point at the end of the shadow going up to the top of the pole. You don't have to make an actual line, but make a drawing and get this angle. And you know, there's various ways. You can take, you know, well, nowadays you can take a laser pointer and set it down here and shoot it up there where it's aimed. You can see it's aimed and is touching the top of the pole, and then just take any means of, you know, a compass or whatever to find the angle here. Now once you got the angle and you got this length from the shadow, you can find the height with trig. And the function you use, since we have no idea what h is, or hypotenuse, so we can't use sine or cosine, but we can use tangent. Tangent is your opposite side over your adjacent side. So you have, well, looks like we just lost everything here, so we'll use a red marker. So you have the tangent of theta equals opposite over adjacent. Well, I know this angle, so I can perform the function. You know, I can take my calculator and find, but I don't know this. I need to solve for this. Well, just like we did in algebra, we arranged the problem, multiply both sides by a, so then we have a tangent theta equals opposite. So you got the angle, you got a, you can do this is all known now. You can find this. That's why a triangle. But now why a circle? That's just one example of a triangle, or of a reason using more of a triangle. Why a circle? Well, it's used more in electronics, and the reason is because we deal with sine waves. Now here's your typical sine wave. Alright? That's one period, it's one wave. After this it just repeats, repeats, and repeats. The same pattern will just keep repeating and repeating. Okay? And so really, what is a sine wave? Well, if I take, say, the bottom half and flip it within my drawing skills, you have a circle. The top and the bottom in a pure sine wave are identical in all respects. And if you just flip one side over, you end up with a circle. And that's why we deal with circles instead of triangles. But triangles are inside the circle. Just drop the straight line down, that becomes your opposite side of the angle. Now you can play with this. You can actually draw this out to as good a scale as you can, and using some basic math and the trig functions, you can draw several different, what they call terminators, at different angles, and see how that relates to your adjacent and your opposite, and those links, from the simple fact that the standard thing about triangles that everybody's learned is a squared plus b squared equals c squared, which can also be thought of as the adjacent side squared plus the opposite side squared equals the hypotenuse squared, which I need to start learning to write that more accurately, which is a small h. But anyway, we started out capital H, so I hope this kind of answers how the two relate and what they are, and that they are the same thing. But you can work out some stuff if you want to, and put in various angles, you know, and figure it out, and just simply do the math and the functions. That's about all I got for you. So on this now, in the second part, and this may go 3 parts, I don't know, maybe 4, but in the second part we're going to start discussing the circle more than the triangle, because that's what is defining our sine wave. And we're going to talk about something, and I'm just going to mention it here. Don't even start writing any comment saying, what are you talking about? Because I will go into it in the next video. But there's, there's actually 3 ways, 3 different angle measurements that you can make of a circle. The 2 primary ones that you see the most, or possibly could see the most, actually the primary one you see the most is degrees, and that there's 360 degrees in a circle. Okay. Another one, and the one that we'll be using more, is radians. There are 2 pi radians in a circle. So to make a complete circle, it moves around 2 pi radians. So 2 pi radians equals 360 degrees. Don't let that catch you up. Don't worry about it. I'll go over it a lot more and discuss it a lot more, and discuss the reason why we use radians and stuff. So anyway, I hope that it answers how the triangle fits in the circle, and how the 2 are related and stuff. So until the next video, thank you for your comments and your questions, and if you have any other questions, go ahead and post them, and I will do my best to answer them. So until the next video, thanks for watching.